Behind me is a very classic number theory problem. For what integers n is n squared plus 6n plus 14 a perfect square? Now, this problem actually requires a pretty common problem-solving technique in number theory, but this technique is very important and it's very, very useful. This type of problem is also pretty common in math competitions, so let's delve right into it. Firstly, if this is ever a perfect square, so if n squared plus 6n plus 14, if this is ever a perfect square, then it can be written in the form m squared for some integer m. Now, this side of the equation, obviously not a lot of terms, so maybe we can try manipulating this side of the equation. Well, we have a quadratic expression here. We can maybe complete the square. I mean, is that a good idea? Well, with nothing else to do, let's try that. So to complete the square, we just take the half of 6 and then, square it. So we have n squared plus 6n, half of 6, 3, square, that's 9. Now you cannot just add 9 for free, so subtract that back and then add this 14 here. And this is still equal to m squared. Now observe that this part, that's a perfect square. We've completed the square. So this is n plus 3 all squared, and then negative 9 plus 14, that would be 5. So plus 5 is equal to m squared. Now consider moving this entire squared expression onto the other side. Then we would have m squared minus n plus 3 all squared is equal to 5. Now notice that over here, this is a square expression. This is also a square expression. We can factorize this side as a difference of squares. So let's do that. We would have m plus n plus 3 times m minus n minus 3, and then this is equal to 5 by difference of squares. Now observe this. Observe that, firstly, we know that m and n, they are integers. So this means that both of these bracketed terms are also integers. And this equation is telling us that the product of two integers is equal to 5. Well, if it's equal to 5, then this would mean that both of these bracketed terms are factors of 5. And therefore, we have severely limited our options. We just need to examine a few cases in which these two are factors of 5. And that is a very common problem-solving strategy in number theory. We should factor an expression so that they equal to the product is a certain integer. And because they're both integers, you can limit their options no problem. So let's examine the limited options that we just need to consider. Okay, so we have our expression here. Recall that this was equal to m squared. Now, because again, their product is 5, they have to be factors of 5. Now, the factors of 5, they are 1 and 5. That's it. 5 is actually a prime number, so that's it. Now, we also have to consider the negative factors as well. Well, why? Because we're not just asking for positive integers. It can also be negative integers. Now, even if it only said positive integers, still consider the negative factors. They could still yield positive values for n. So even if it was positive integers, still consider the negative ones, okay? Okay, so we have our factors of 5. So if one of these terms is equal to 1, then the other has to be 5, and vice versa. And if one of them is negative 1, then the other has to be negative 5. So let's just test our cases. Let's see what we can get from examining certain cases. If this is equal to 1 and this is equal to 5, then we have a system of equations. This would mean that m plus n plus 3 is equal to 1, and m minus n minus 3 is equal to 5. Now, of course, with systems of equations, this one looks very convenient for elimination. So let's just subtract equations. M minus m, that cancels. N minus negative n, that's 2n. And 3 minus negative 3, that would be 6. And this over here is negative 4. And then we have 2n is equal to negative 10. And n is equal to negative 5. So that's one value. Now, when you get a value like this, it's often very important to check that m is also an integer, because if this is an integer but m turns out not to be an integer, then this is invalid, right? Because both n and m have to be integers. Thankfully, over here, we can conclude that m also must be an integer because it's just 1 times m. So if you plug in n to be -5, like we found here, you would solve for m would still be an integer. And of course, we have to add to our list of solutions. So n can be equal to -5, like we found. Okay, that's great. Now, we have more cases. So we've considered a case when this was 1 and this was 5. Let's swap them. If we swap them, we would have 5 and 1. Again, the same deal. System of equations. M plus n plus 3, this is equal to 5. M minus n minus 3, that's equal to 1. Again, we can use elimination. So we have 2n plus 6 is equal to, that's 4. And 2n is equal to -2. N is equal to -1. Again, we know that in this case, m will be an integer as well. So get my purple marker. We have another solution, -1. It will also make this a perfect square. Now, we need to consider the negative factors now. So one case is that if this is equal to -1, then this over here is -5. Then, okay, I'm not going to erase it. I'm not going to erase the entire thing. I'm just going to replace the ones that I need to replace. So -1 and -5. So again, this left-hand side will still be the same when I do the subtraction of equations. The right-hand side, I just need to do the appropriate subtraction. That would be 4. Now, over here, we would have 2n is equal to -2 once again. Okay, well then n is equal to -1. That's the same solution over here, so we don't add anything to that. Now, of course, we have one more case remaining. What if we had this over here was -5 and this was -1? Okay, well then, over here, we just swap them. So we would have -5 and -1. Great. Now, over here, we just need to do our appropriate subtraction. -5 minus -1, that would yield -4. Okay, and solving for n, well, we would just get the same thing again. We get -5. Oh well, we don't add anything. So therefore, the only values of n such that this is a perfect square will be -5 and -1, both negative. Pretty cool. Okay, so that's it for today's video. I hope you learned a bit of number theory and how to solve number theory problems like this one. Remember, factor. If you factorize an expression and it's equal to an integer, and you know that both of those factors must be an integer as well, then you've limited your options. In this case, we only had to consider the few factors of 5. So always remember that factors are very important in number theory problems. Anyway, thank you very much for watching this video. I hope you found it very interesting. If you did, please do consider dropping a like and subscribing. Thank you very much. Bye.